So if you've ever walked into a massive building, say a hospital or a stadium, and wondered how they get a live camera feed onto a specific TV channel, this deep dive is for you.
It is. We're looking at a very specific piece of hardware that solves that exact puzzle. The Thor Broadcast H-2HDMI-ATSC-IPLL modulator.
That model number is a mouthful.
It is, because the job it does is deceptively complex. Our mission here is to understand how this little box acts as the ultimate bridge.
A bridge between what and what?
Between modern digital video from any HDMI source, a camera, a PC, anything, and a traditional standard over-the-air television signal.
So you're saying it lets you create your own TV channels like for a private network?
Up to 4 of them, in high definition, exactly.
And that's the core of what we're digging into, right?
Right.
Taking a consumer input and turning it into a professional broadcast signal that can run over miles of old copper coax.
Right, so its fundamental job is conversion. It takes that HDMI video up to 1080p 60 and has to turn it into a radio frequency signal a normal TV can find.
And that conversion isn't just random, it has to follow very specific rules.
Very strict rules, especially here in North America. We're talking about the ATSC standard. It's the digital handshake that every TV tuner in the US and Canada is built to understand.
Okay, and that uses a specific method, 8 VSB.
8-level vestigial sideband modulation. Yeah, 8 VSB.
So why is that specific standard so critical for the people installing these systems?
It comes down to stability and range. If you're managing a huge facility, you've already got thousands of feet of coaxial cable in the walls.
You're not going to rewire the whole building.
Of course not. And while 8 VSB offers a bit less data than other standards, about 19 megabits per second, it is incredibly robust.
Robust how?
It's designed to push a clean HD signal through long, old, noisy cables without dropouts. It lets an integrator inject their own local channels right alongside the ones coming from the main antenna.
And you can make these channels look official with
Wow.
channel numbers and guide info.
Oh, absolutely. You can figure all that through a web browser. You set up what are called PSIP tables.
That sounds technical.
It's just the channel name and the program guide data.
Yeah.
You assign it a channel number, give it a name, and to every TV in the building, it looks completely legit.
Okay, this is where it gets really interesting for me. The LL in the model number, that stands for low latency.
It does. And for live events, this is a complete game changer.
Why? What's the standard delay like?
It's huge. Most standard H.264 encoders introduce a delay of 700 to 1200 milliseconds.
So, almost a full second.
A full second lag. Imagine being at a sports bar and hearing the crowd cheer a full second before you see the goal on the screen.
That would be awful. It would ruin the experience.
Exactly. This LL option, it crushes that latency. It drops it by more than 10 times down to the 70 to 120 millisecond range.
Which is basically real time.
It's so close you'd never notice. And that makes it perfect for things like live corporate town halls or monitoring security feeds where you need to see what's happening as it's happening.
You know, I noticed that the unit packs everything into one box. The encoders, the multiplexer, the modulator. That's great for saving space, but does that create a single point of failure?
That's a great question. And it's a valid concern, but the flexibility here kind of mitigates that risk.
How so?
It supports both the modern H.264 and older MPEG-2 video codecs, plus different audio codecs, so it's compatible with almost anything you plug into it. And since it's fully network managed, you can monitor the health of every part of it remotely. It's built for robustness.
So what this all means for you, the listener, is that this device is a powerful, very flexible bridge. It takes simple HDMI video and transforms it into a professional signal for an internal network.
Whether that's over old school coax cable or modern IP streaming. And if you just stop and consider that, the ability to run private low latency HD live feeds over existing infrastructure, it really highlights something important. The need for this kind of controlled video distribution in, say, a government building, a university, or a hotel, it's still driven by the sheer reliability of the coax cable already in the walls. That legacy tech is nowhere near obsolete when a device like this gives it a modern digital brain.